All right. This is how to obtain the formula of slope and intercept using OLX under simple linear regression analysis. So this topic is meant for those offering statistics, those offering econometrics, those in accounting also, and statistics right now. So the question there is, how do I obtain my slope and intercepts under regression analysis, okay, OLS, ordinary least square, using simultaneous equation? Let's write this linear equation that we all know: y equals to beta naught plus b1 x. This is a linear equation. Then in the given model, there are some models that are deterministic in nature, and there are some models that are probabilistic, which are non-deterministic. Now this model written is deterministic in nature. The reason there is that there's nothing like random error or residual error. Alright, to make it more simpler and make the video more concise and precise, so that's why I'm not including random error. So we also have other methods in solving differentiation approach, the matrix approach, but this I'm using the simultaneous equation approach, either substitution or elimination. So doing this, firstly, what's b naught? B naught is my intercept, while b1 is my slope, intercept, slope. Now how do I obtain my intercept? How do I obtain my slope? Using the OLS by the approach of simultaneous equation. So I'm having y equals to b naught plus b1 x. Firstly, in this expression, multiply both sides by summation. Multiply both sides by summation. So how do I multiply both sides by summation? This y, that will be summation y. Then for b naught, since in the table, if you are conversant with regression analysis very well, in the table you can't have something like summation b naught. So in order for me to use summation b naught, so I will represent summation as n. Okay, for b naught, this will be n b naught plus, then I'm having x here, then the summation will be affected here, so that will be b1 summation x. Call this equation 1. So from equation 1, multiply both sides by x in equation 1. Multiply both sides by x, that will be summation xy equals to, here that I'm having n, represent that summation. Since x is affected, that n will change to summation. So this will be b0 summation x plus b1 summation x multiplied by x raised to power 2. This is equation 2. So I'm having equation 1, equation 2. And equation 2. From equation 1, alright, from equation 1, I could make my b naught, which is my intercept, the subject of the formula. So equation 1, which I have summation y equals to nb0 plus b1 summation x. So make b naught subject of formula, If I want to make the b naught subject formula, I will collect like times by transferring b1 summation x to left hand side, when I mean left hand side. So this will definitely be summation y minus b1 summation x equals to nb0. Now since I'm having this, I want to make b naught subject of the formula, so therefore I will divide both sides by n. So therefore this will be summation y minus b1 summation x over n, b naught summation over n, cancel. B naught will therefore be equals to summation y over n minus b1 summation x over n. Bear in mind your mean is x bar, right? Mean simply means summation x over n. I could the same thing as y bar could mean summation y over n. So b naught is equals to summation y over n, that would be y bar minus b1 summation x over n is what? X bar. So this is the estimate of your intercept. So from here, let me just call this equation 3. Now how do I get my b1? I'm going to substitute this b0 in equation 2, since b0 was derived from equation 1. I haven't touched equation 2 at all. So how do I substitute that? So therefore that will be okay. Going by that, I'm having equation 2, I'm having summation xy equals to b0 summation x plus b1 summation x raised power 2. Okay, this is what I'm having. Now what's my b0 rather? b0 is summation y over n minus b1 summation x over n. Then substitute this in equation 2. So that will be summation xy equals to b0. That will be summation y over n minus b1 summation x over n. Put it in brackets. Summation x plus b1 summation x raised power 2. Now I'm making b1 subject of formula. Open the bracket. Summation xy equals to, when I'm opening the bracket, I'm having summation x summation y over n minus b1 summation x times summation x all raised power 2 plus over n plus b1 summation x2. So I'm making b1 subject of formula here. So I will need to transfer this to the right hand side. So this will be summation xy minus summation x summation y over n, right, equals to b1 summation x raised power 2 minus b1 summation x all raised power 2 over n. If I should factorize b1, or let me find the LCM here by saying over 1, so this n and this also n multiply this n summation xy minus summation x summation y equals to b1 and b1, okay, summation x square minus b1 in bracket summation x all raised by 2. Then this could cancel this, okay, this could cancel this denominator. Since they were both equal, you could cancel this. Then I will be left with n summation xy minus summation x summation y equals to n b1 summation x square minus b1 summation x all square. So I'm making b1 subject of formula. This common, b1 is common. I'm going to factorize there. So n summation xy minus summation x summation y equals to b1 into bracket n summation x square minus summation x all square in bracket. So make b1 subject of formula. So b1 will be equals to n summation xy minus summation x summation y over n summation x square minus into bracket summation x all square. Final answer for your slope. So this is the formula for our slope, and this is the formula for intercept using regression analysis. Thank you for listening. Do well to like and subscribe.